Hey guys, welcome back. And from this video, we are going to cover doubly linked list, and our next video is going to be circular doubly linked list. And before starting, you can say before going on to the coding part, let's understand what's the difference between a singly linked list and you can say a doubly linked list. Basically, in this doubly linked list, what we have is our node, which initially had one value that was you can say you can keep anything. I have kept its current, and one single edge, which was we were telling is the next. But now we also have one more edge, which is pointing towards previous. So basically, what happens is initially this was our singly linked list, which where each node was pointing towards its next node. And in doubly linked list, what happens is basically each node is pointing towards the next node and also pointing towards its previous node. And if we want to check an example of or give, get an example, then what happens is suppose you have a Spotify playlist and every time you start a playlist, you have an option to go back to the previous song as well. Initially, with you can say singly linked list, this was not possible because directly we are pointing to the next song. So you only had an option to play the next song, which was after the particular song, which was played. Now over here, you get the option to you can say move on to the next one or come back to the previous songs as well. And as you can see, this is our doubly linked list, and each node is pointing towards the next node, and also the next node is pointing towards the previous node. Along with that, we have our head and tail pointers. Head pointer is the start of the linked list, tail pointer is the end, and the last node is pointing towards none, and the first node previous pointer is pointing towards none as well. Now, before moving on to coding, let's understand what are the functions which we are going to cover and how they work. So initially, suppose this is our doubly linked list and we want to insert a node at the end of the linked list. So what we'll do initially is we'll remove this, like the tail node which was pointing towards none. Now this node will start pointing towards our new node and the new node will point towards none. Now the new node which we have created will also have a previous pointer and that previous pointer will start pointing towards the previous last node or you can say the tail node. And then after the node has been added successfully, we'll move the tail pointer towards our last node, which is our new node H, and tail pointer will be pointing towards H. And this is how we will successfully add our, you could say, or append a node into a doubly linked list. Now let's move on to the next function where we will add a node at the start of the linked list. It is simple as well. The new node will start pointing towards the old head node, and then the old node, that is A, will point towards H. And what we'll do is remove the head node like this, and the head node will start pointing towards the H node, which is new. And you can say the this node, which was new, will also have its initial pointer as none. So let me add it over here as none. And as you can see, this none pointer will be over here, and the previous pointer will point to none. This is how we will be prepending a node. Now let's talk about appending a node and how it will work. Sorry, appending a node in the linked list at any given index. So what we'll do is initially we'll create a temp node. We will start iterating from A, we'll start to B, we'll start to C, and let's assume that we want to add a new node over here, that is E. So we'll go towards D and we'll stop here. Now what we'll do is initially we have a link between D and E, that is the next node of D is pointing towards E and the previous node of E is pointing towards D. What we'll do is initially we'll start pointing this, D will start pointing towards H and H will start pointing towards E, then E will start pointing, or E will again point towards H, and H will again start pointing towards D. And then we'll sever this so that the bridge is gone. And what this will do is basically we are adding a new node over here. So what we'll do is we'll iterate until we reach a node which is previous than our intended index, and we'll add a node. And now when it comes to deletion or when it comes to deleting a node from a linked list, let's start from the head part. So let's assume we want to remove a node from the start of a linked list. Then what we'll do is initially we'll shift a pointer of a head. We'll shift the pointer over here, and then B will be our head node, and we will remove the pointers between each other. Like A, which is pointing towards B, and B, which is pointing towards A, will be removed. Then A is severed, and this B node will now point towards none. So this is our new linked list after removing the head or the initial node of the linked list. Now, Suppose we want to remove a linked list or a node from the end, then what we'll basically do is, let me copy this. This a tail is not yeah. So what we'll initially do is, we'll remove the tail pointer from here. We will keep it over here. We'll attach it to S. We will remove the next and previous pointers, and then F will start pointing towards none. So what happens is, this is how we remove a node from the end of a linked list. And to remove a node at any point of a linked list, what we'll do is, we'll start from initial node, and let's suppose we want to remove the node D. Then what we'll do is, we'll go till node D, and or we'll iterate from the start, and we'll go till node D. Then what happens is, let's take it down. Then what we'll do, C will start pointing towards D. So basically, this node will start pointing towards E, and E will be made to point towards C. And once this is done, the D node, which has the pointers to it, will also be severed and made none. So the next pointer in D and the previous pointer in D will be none. And this is how you can say remove a node from a linked list, doubly linked list, and keep the linked list intact. We'll also cover, you can say, pointers or functions like search. We'll search with a value, we'll search with an index. Along with that, we will also cover a few functions and such as get. We'll get with an index, and we have a different method for getting as well. So suppose we have a particular index over here, which is pointing towards f, or let's say we are finding f. You know that f is basically at, you can say, more value, or the index is greater than the center. Suppose we have 1, 2, 3, 4, 5, and 6. We have 6 nodes, and f is at the fifth part. And we'll suppose we divide this linked list in the middle. So what we'll do is, we have self.length as a parameter. So if we divided it, and if the index is greater than the you can say half the length of the linked list, then we'll start iterating from the tail part. So what happens is, if we want to find a value which is over here, such as B and C, iterating from the head part will get it, or will make us get to that particular point quicker. While if the value is over here, E and F, then starting from the tail part will iterate towards the previous counters or the previous nodes, and will get here quicker. So this is how our entire logic is going to work. Now let's get to the coding part, and let's start coding it. So initially, or the process will be same. We'll create our node class. We'll create our initial function, and our initial function will, as usual, take our value, which is the value for the node. And what we'll do is, self.value will be value. Then we have our two pointers as self.next, which will be none, and self.previous. So we'll write a short form, and will also be none. Now let's create a, when say, class for doubly linked list. Doubly and linked list, and we'll create an initial function for it as well, and it will take self as an argument. We'll go over here. Self dot head will be none. Self dot tail will also be none. Till the length will be equal to 0. So by writing this function, we can initialize our doubly linked list, and yeah, it will be an empty doubly linked list. So now we'll write a append function, which will add a node towards the end of the linked list. So it will take value as an input. This will be the value for the node. So we'll check like this: new node is equals to node, and we'll pass on the value so that the node is created. Now we'll check if, yeah, self.head is null. That means that there are no nodes inside a necklace, that or the necklace is empty. So what we'll do is, self.head will now point towards this new node, and self.tail will also point towards this new node. Along with that, if that is not the case, then what we'll do is we will move on to the self.tail dot next. That is the next value will point towards new node, which was initially none, and then self dot tail, or you can say self dot tail will now point towards new node, and okay, I forgot this. What we'll do is before moving the tail pointer, we will need to add a previous counter as well. So new node dot previous will now equal to self dot tail. So it is pointing towards the previous node as well. And then what we'll do is self dot tail is equals to new node. And at the end, what we'll do is self dot length is plus equals one. And we are done with this function. Along with append, let's create prepend as well. This will save some time because it is quite simpler as well. And it will take value as an input and new node is equals to node and we'll keep a value to it. And then we'll check self dot head is none. Self dot head is none. Then what we'll do is self dot head will be pointing towards new node. Self dot tail will be pointing towards new node. And if that is not the case, then okay, that is not the case, then what we'll do is initially new node will be dot next will point towards self dot head, then self dot head dot previous will point towards new node, and then self dot head will start pointing towards our new node. And this is how we have successfully appended. Oh yeah, let's increase the length as well. Length plus equals 1. And this is how we have successfully implemented this you can say prepend function. And now what we'll do is let's create a str function. And if you don't know what str function does is, you need to you can say refer back to my videos or just understand how it is working over here. So str function, what it will do is basically it will iterate over our linked list and write, you can say, give us the output which shows the entire linked list. So if you just basically print our linked list class or the variable which is assigned to our class, then what happens is you'll get a random address popped up. So it won't be, you can say, easier to debug and see if the variables are added or our functions are working. And in order to visualize it, we are creating this function. So what we'll initially do is we'll create a value which is values as here, and this will be an empty list. Now we'll write temp node is equals to self dot head, and while temp node is true, we will start appending the values. Values dot append str. I will here temp node dot value, and then temp node will be equal to temp node dot next. That means we are moving ahead. We are moving towards the next node. Next node. And once this is completed, we'll return our entire linked list. So we'll return something like this. Let's create a dual side arrow and dot join values if values else or if else as empty. Now let's try this out. Let's create our class, initialize a function. You can say initialize our class. So doubly linked list, and this is done. Now what we'll do is dot append. I'll add a few values. Now I have added this, so let's create a prepend method or is the prepend method as well. We'll prepend one. And finally, let's print our linked list. So this is done. Let's test it out if it is working. And as you can see, we have successfully created our linked list. Now let's move on to a new function that will be a reverse traversal. So as you guys know, like we have already traversed over here and we are getting our linked list complete. So what we'll initially do is we will create a reverse traversal function. Where what we'll do is we'll start from the tail pointer and we'll move on to the first pointer. What happens over here is we'll create a temp node which will be self.tail and while temp node what we'll do is I'll print temp node dot value and we'll do temp node is equal to temp node dot next and our browser function is done basically. So let's test it out over here and let's add it over here and let's see if it is working and it is just printing 10. Okay, instead of next, what we had to do was we had to write over here as tail. Previous, sorry. Yeah, we need to write previous over here. As you know, like the next function is directly 10. So it will, after 10, it will move to none and which will end the loop. Meanwhile, we had to go to its previous. So we moved from 10, 9, 8, 7, something like that. So let's test it out. And as you can see, we have got printed over here. We started from 10 and ended at 1. You can simply copy this one as well. This was just for an understanding purpose. Like we could have implemented it like this, but this is better for understanding. So as you can see, we have started from 10 and we have started from 10 till 1. Now, what we'll do is we'll move on with our next function. So we'll start with a search value and where we'll be searching a particular value inside our doubly linked list. So it will take some comma value which we want to search. What we'll do is we'll check if the linked list is empty or not. Also, guys, I haven't covered all the edge cases in this, you can say, video. There are, or there could be many edge cases which needs covering. So you can try them out, or if you have any doubts, you can write it inside the comment section. I will definitely answer them. So once we have checked if the linked list is empty, and if it is not, then what we'll do is, let's go this way. What we'll do is basically we'll create a temp node which will start from self head and we'll create an index as well. It will start from 0 while temp node what we'll do is if temp node dot value is equals to our the value which we are looking for, then we'll directly return true or we'll return the index of the, you can say, the value where it is present, and if it is not, what we'll do is temp node will move on to the next temp node and if will increase the index as well plus equals 1, and if we don't find then we'll return false. Let's check this function out if it is working or not. We'll comment this. Let's run search and we'll need to enter the value. Let's search for 10. It is the last value. Let's check find it out. So that type set what head is not head what it is. Set what head is none. Okay, is not factorable. Let's see. So not and we have pointed it correctly, index is correct, and we have integrated this. If temp node is value null if index, then we are moving from next and we are returning this as false. I don't see any error over here. DLL dot search and we are searching for 10. Correct? And we already have 10 over here. What's the issue? Self dot head is none over here. Let's see. Okay, self dot head in none. Okay, I got it. So I was just looking in the else, like what was not a table, and yeah, it is over here. Is this the error? And now let's see if it is working. And as you can see, we found it at a index of 9. Since it starts index from 0, we get on it with 9. So this is successfully working. Now let's move to the next function, and it will be get value at index. So it will take self and it will take index. What we'll initially do here is if index is less than self dot length ls of 2, and as I said, like in the video explanation, we'll compare it if the length is less than index, or you can say the length of the linked list, which is half, and if it is of the index is less, then we'll start iterating from the head part. So what we'll do is temp node will be equal to self dot head, and for this store in range till index, what we'll do is temp node will be equal to temp node dot next, and if it is not the case and if the index is bigger, then our temp node will be equal to self dot tail, and for also in range self dot length minus 1 till index, and it will be minus 1 as well. So the counting or the range works in a reverse order. Then what we'll do is temp node will be equal to temp node dot previous, and like this, and in the end we'll return temp node dot value. So let's test this function out and see if it is working. And instead of search for this, and we'll need at the index of 10, which we don't have. So what we'll do is, since we haven't covered that case, I'll just search for 5, which is already present. And let's see, and it is at the index of, or at index 5, we have the value as 6. 1, 2, 3, 4, 5, and yeah. Since it starts from 0, we are over here, and 6 is at the index of 5. So this function is successfully implemented. Now we'll, you can say, work on a function that is setting a value or where we are updating a value inside a linked list. So we'll name this function as set value. What we'll do is we'll make it value comma index. And also here you can use the method I have used above, which will, you can say, reduce the time of the linked list for updating, but I'm not using it here because it will increase the length of the video. So what we'll do is self head as none, then we'll return it as empty, and else what we'll do is then to know is equal to self.head, and for range index we'll move temp node equals to node dot next, which will take the node towards the next node. or will our traversing the node and will update the value in the end. Value is equals to value. And with this, we have successfully implemented this function as well. Let's see if it is working. And what we'll do is over here we'll try. We'll remove this, and we want 5 to be updated at the index of 5. Let's see. And then let's print over this, and we'll see if the index has been updated or not. So as you can see, initially it was 6 and now it is updated to 5. So we have correctly implemented this. And now we'll move on to the next function, that is insert inside a linked list. So what we'll do is insert linked list. It will take fill, comma, value and index. So initially what we'll check self.head is none, then return empty, else if index is equal to 0. So what we'll do is we'll directly run our prepend function and we'll put the value inside it. Else if our index is equal to self.length, then we'll say append the value. If we take some space and here we are. And if that is not the case, then what we'll do is we'll create a new node. Then we'll start iterating. So for iteration, we need a temp node, which will be self.head or underscore temp range. Next minus 1. We'll see temp node is equals to temp node dot next. And once we have reached over here, we'll start implementing our main logic. So temp node dot next will be equal to, or you can say we have already over here, correct? So we are here. And how will update is, so initially we want to, suppose we want to update 7, then we are currently at 5. Then what we'll do is, or we want to add a new node between 5 or 7 over here. What we'll do is, initially we are over here and we will add the new node. So 5 will start, or the next node will first point towards 7. So what we'll do is, new node dot next will point towards temp node dot next. So after pointing, you can say we are inputting, let's consider 17. So now 17 is pointing towards 7. Now that 17 will previous pointer, so new node dot previous will point towards the temp node. And once it is done, then what we'll do is we will update the temp node dot next dot previous will be pointing towards our new node. So basically 7 is now pointing towards our new node, that is 17. And then temp node dot next will point to our new node as well. And then at the end, we'll increase the length. So plus equals 1. So let me give you an overview. We have 17, which is going to be inserted between 5 and 7. So what we did is we iterated our linked list from the start till, you can say, we got till 5. Then what we did is 17 started pointing towards 7. Then 17 started pointing towards 5 as a previous node. Then what we did is 7, which was previously pointing towards 5 as its previous node, is now started pointing towards 17. Then 5 started pointing towards 17 itself. So this is done, and let's check it out if this is working correctly or not. So what we'll do is before here, we'll import, you can say 17 at the index of 5, and let's check it out if it is working. So 1, 2, 3, 4, 5. And yeah, as you can see, if we start from counting from 0, 0, 1, 0, 1, 2, 3, 4, and 5. 17 has been successfully added over here, and we have completed this function. And we'll now move on to, you can say, deleting all the functions from our linked list or the deletion functions. So let's start from pop. As you know, pop removes the last element from the linked list. So we'll directly create a temp node which will be pointing towards tail. Now what we'll do is if self.head is equal to self.tail, that means you can say there is only a single node inside the linked list. Then we'll directly do self.tail is equals to none, and self.head is also equal to none. And we have successfully removed it. And if that's not the case, if we have multiple nodes, then what we'll do is self.tail is equals to temp node dot previous. So you can say self.tail has moved back a node, and then temp node dot previous will the previous dot, you can say, next will now point towards none, and temp node dot previous will now point towards none as well. So what happened over here is initially our tail was pointing towards 10, then we moved back the tail pointer at 9, and what we did was initially after moving the tail pointer towards here, temp node dot previous means tail, we moved to 9, and 9 had a pointer pointing towards 10, which we made none. And then what we initially or did at the end was the previous pointer of 10, which was pointing towards 9, is also made none. And at the end, we'll do self.length minus equals 1. So the length has been reduced. After this, let's create a function for pop first, or you can say removing the first element. And this is how it will go. Self will check all these functions at the end once we have created all these functions. So temp node over here will be pointing towards head, and now if we copy it from here only, it's the same case. So and then else what we'll do is temp node dot next node previous will now be equal to none. Then set dot head will point towards temp node dot next, and temp node dot next will be equal to none. So what we did was initially, in order to remove one, we initially went to two, that is next, and the previous pointer to it. So the previous edge which was pointing towards one, we made it null. So the double connection was severed, and now the two previous pointer, the previous pointer of two is now pointing towards none. Then we moved our head pointer towards two. So from one it went towards two, and then what we did is the temp node which was one, which was pointing towards two, with its next edge. We made it null, and we successfully removed it. And at the end, let's decrease the length minus equals 1. Now let's move on to, we can say, our second last deletion function, uh, remove. So what it will do is basically remove any node at the index we provide. And this is how we are going to do is we will initially write self dot head as null will check. If self dot head is none, then return 20. Then what we'll do is we'll check if index is equal to self dot length, then we'll get to the pop function, and if index is equal to 0, then we'll get it to s self dot pop first. So our first element will be removed. And once it is done, we'll create our else case, like if the index is in the between. So what will happen is we'll create a temp node that will be self dot head. You can also traverse from tail, and you can also implement, you can say the middle logic, which I said, like starting from dividing your linked list from middle and comparing the height. And if the index is greater, then you can start from the tail side, and the index is less than the middle or the half of the linked list, then you can start from the head as well. I am starting it, you can say from head anyways, so it won't be an issue. Next minus 1, then we'll check temp node, which will be equal to temp node dot next. And what we'll do is pop node is equal to temp node dot next. That is, if we want to remove 8, then we iterated towards, you can say, 7, and we created a pop node, which is this one, which is pointing towards 8. So temp dot next is pointing towards the node to be pop, and it is pop node. What we'll do next is temp node dot next is equal to pop node dot next dot next. Now pop node dot next or alias is equals to temp node. So what we did over here is temp node dot next, which is, you can say, ninth one, is now, you can say, from seventh one is the temp node, and temp node dot next is our eighth node, which is now pointing towards pop node dot next. So what we did is we started, or we edited 7 to now point directly towards our 9. So and after this pop node dot next dot previous, that is from 8, our next node is 9, and 9 previous counter was initially, or the edge was initially pointing towards 8, which is now directly pointing towards our temp node, which is 7. And after pointing that, what we'll do is pop node dot next equals none, and pop node dot previous is equal to none, and self dot length minus equals 1. We have removed, suppose for 8 initially was pointing towards 7 and 9, we have removed those edges, and after this let's create our last function, that is delete. It will delete the entire linked list. So self over here will move this cell, and what we'll do is self dot head is equal to none, self dot tail is also is equals to none, and then self dot len will be equal to 0. And we have successfully implemented our entire linked list. Now what we'll do is we'll now start testing our functions. So over here, what we'll do is ll dot pop will run dll dot pop first, and then we'll run dll dot remove, and we'll remove index at 3, see if it is working, and then we'll print our DL, And then what we'll do is we'll run our delete method, which will delete our entire linked list, and then again try to print it. Let's see if all the functions work. And if we see, we have removed them. So pop initially removed our last. What we can do is after every function, we can print it over here and over here. This. So as you can see, pop removed the 10 over here from 10, which was the last one. Then after this, we removed 1, which was the first node. And then we remove, we can say 3. So we remove 3 over here at the index of 3. 0, 1, 2, 3. 5 was removed. Since we have 2, 5, now we have 1, 5 over here. And then at the end, you can see we have empty double linked list after that.